Hi further students. In this video we're going to go through an example of finding the best transformation. This example is from the end of our chapter 5 notes, and it's a question where we've got some nonlinear data and we're going to try to choose from a series of transformations and try to pick the one that does the best job of making the relationship between our variables linear. So let's get stuck into it. We're given some information about a circular petunia garden. It doesn't really matter if you know what that type of flower is or not. At the Melbourne Garden Show, and the number of seeds planted in a row apparently can be predicted from the row number. And then we have the row number and then the number of seeds in each of those rows. And we're asked to use CAS to plot this data on a scatter plot and sketched in the space provided below. So I've got the work solutions already entered in here. We're just going to kind of go through them. But one of the first things we would have to figure out is which is the response variable and which is the explanatory variable. And the key is in this sentence at the top. It says that the number of seeds can be predicted from the row number. Okay, so in other words, if we know something about the row number, we can use that to figure out something about the number of seeds, which indicates that row number is influencing number of seeds, which means that number of seeds would be our response variable and row number would be the explanatory variable. So those row number values need to go into list 1, which I've already done here on the calculator, and the number of seeds values need to go into list 2. And to answer question 1, well, we'd be generating the scatter plot on our calculator. As I said, once that data's in there, we can go set graph, make sure our settings are right. We want a scatter plot for list 1 against list 2 because it's just the original X and Y values. We hit set and we tap our graph button, and there's our scatter plot. And you can see that I've just drawn a bit of a sketch of that scatter plot by hand. I've labelled the axis with row number and number of seeds, explanatory always on the x-axis, and there we go. Next part of the question says, is our data linear? And pretty clearly, no, it's not, because our scatter plot shows a curve, so no issues there. And then the next part of the question says, in question 3, what types of transformations would be appropriate to use to linearize this data? So we have to go to the circle of transformations from our notes, and this is on the very first page of your chapter 5 notes. And our scatter plot, which is still in the calculator here, most resembles the bottom right-hand part of the circle, so this scatter plot here. And the 3 options for transformations here are log of y, 1 over y, or x squared, and those will be our 3 possible answers, log y, 1 over y, and x squared, but we're supposed to answer in terms of the variables, so that becomes log number of seeds, 1 over number of seeds, or row number squared. All right, here's the tricky bit. In question 4, it says to apply these transformations, and for each of them, we have to sketch the scatter plot, sketch the residual plot, and calculate r squared. So we've got to go through one by one each of those transformations and see which one does the best job. The first one is log number of seeds. So this would be taking the log of the y value, and remember, we're going to go through this on the calculator, even though the answer is already on the screen here. So on the calculator, we would use list 3 for our transformation, and at the bottom of list 3, we'd be typing in, using ABC. We want, oops, sorry, I've jumped the gun there. Before we go to ABC, we need to put log 10, and then it's log 10 of list 2, because we're taking the log of the y values. And remember that when you hit execute here, your value should appear in list 3. Okay, and so one by one, let's do the scatter plot first. If we're going to then construct a scatter plot for this transformation, we go set graph and setting. We've changed the y values, so y list becomes list 3. X list stays as list 1 because we haven't changed the x variable. We hit set, we hit graph, and we get our scatter plot. Now this is automatically drawn the regression line. We don't need to have that there. We can just ignore it. You can see that it's forming a pretty close to a perfectly straight line. If you don't want that regression line there, you can go into your settings and untick previous reg, and that'll get rid of it. And there's a pretty good picture of our transform scatter plot, and you can see I've just drawn a little rough sketch by hand on the notes here. To get a look at the residual plot, we obviously need to get some residual values, and the way that we do that is to back up the top here, go calc regression linear reg. Again, we change the y values, so we're going to make y list list 3. This time we need the residual values, so we're going to copy them into list 4. Remember, we'll always do that. We'll copy residuals to list 4. And we hit OK. Now, while we're here, we might as well write down the value of r squared as well, because that's what we're being asked to do. R squared is very, very high here. It's 0.99985. And when you round that to the nearest, or when you round that to 2 decimal places and then convert it into a percentage, we actually get 100%. So we've got an extremely high r squared value here. So we hit OK, and our residuals will now be in list 4. So to construct the residual plot, we go set graph and then setting. This time, X list, if we haven't changed it, stays as list 1. Our Y values for a residual plot are always the residual values, which are in list 4. So Y list becomes list 4. We hit set, we're going to tap the graph again, and this time we get a residual plot. We know it's a residual plot because the horizontal line is going through the middle. And you can see that the points here, arguably, at least at the start, there's a little bit of a U shape, but they seem to sort of bounce up and down, above and below 0 in a much more random way, certainly than what the original data would have. So again, just drawn a little sketch by hand of the residual plot. And so just from looking at the three things, particularly that R² value, this looks like it's done a pretty good job of linearizing the data. But we're being instructed to do the three different transformations and see which is best, so we've got to do the other two. Next one along is the reciprocal of y, 1 over y, or in this case 1 over number of seeds. Again, you can already see the answers there, but let's just go through how you would get them on your calculator. So this time we would be using list 3, so we're going to change list 3 here. I'll just resize this, make it a bit bigger. We're going to change list 3. We're no longer doing the log of list 2. This time we're doing 1 over list 2, which is 1 divided by, and again on your keyboard, type in list 2. And we get some new values appearing in list 3 there. And so to do the scatter plot, well, we can do that now. We can go back into our settings. This time we want a normal scatter plot. So we've got X list as list 1. Again, we haven't changed the X variable. The Y list is list 3 because that's where our new Y values are. And so for the scatter plot, those are the settings we want. Again, let's put that regression line in there, which is a little annoying, but you can untick it. And this is our new scatter plot after the transformation, and that's been copied down here. And you can see that it's not done a great job of making the data linear. This has definitely still got a pretty pronounced curve to it. The residual plot, well, if we want to come up with a residual plot here, we know that it's probably going to produce something that looks nonlinear, but we need our residual values for this transformation. So we do that with calc, regression, linear reg. X list is list 1, excuse me, Y list is list 3. Copy the residuals into list 4. That will just copy over anything that's already there. Hit OK. Again, like we did last time, we can actually get R² at this screen before we clear it. So we've got R² equals 0.783. So to 2 decimal places, that would be 0.78 or 78%, much lower than the previous one. We hit OK. And remember, we're trying to do our residual plot here now. So we go back into our graph settings. And with the residual plot, the Y list will be list 4. Hit set. Tap the graph button. We don't want the previous reg, we don't want that regression line in there at the moment, so we just untick that. And you can see that we get a pretty pronounced U shape, indicating that we've got still got nonlinear data here. Okay, so that hasn't been such a successful transformation. Third and final one, now it's a little repetitive, we've got X² or row number squared. Okay, so to perform this transformation, we're still going to use list 3, but we're going to, rather than take 1 over y, I'm going to clear that, and we're going to put in, using ABC on the keyboard, list 1, because we're now transforming the values in list 1, the X values, list 1 to the power of 2, and hit execute, and that's going to square all of our X values. Okay, so there's our new transformed values into list 3. If we're going to try to produce this scatter plot, we would go set graph and then setting. And this time, we've changed the X values, so they become list 3. And we're using the original Y values, so we just use Y list as list 2 because they're not changed in this third transformation. We hit set, we hit graph. Repeat the process. Again, we get a scatter plot that still looks like it's got a bit of a curve to it. We actually have a few data points really clumped down the bottom there. Might be a little bit hard to see them all separately, so you could hit analysis and then trace just to highlight them. You can see there's sort of 3 of them down there pretty close to the origin, and then they spread out a little bit after that. And so there's a bit of a sketch of our scatter plot. Again, to produce the residual plot and to get R², we're going to use calc, regression, linear reg. We changed the X variable, so X list becomes list 3, Y list stays as list 2. We want the residuals copied to list 4. Hit OK. R² we can get from this screen, which is 0.8977, which to 2 decimal places would be 0.90 or 90%. Okay, so a better R² than the second transformation, but still not as high as the first one. We hit OK, and then in our graph settings here, we can set it up for the residual plot. Now the X-axis will actually be row number squared. okay, on the residual plot. So we do need to leave the x list as list 3. The y list will be the residual values there, list 4. Okay, so if you have transformed your x variable on the residual plot, the x variable needs to be list 3. All right, we hit set, we tap the graph button. Again, we can get rid of that regression line if we want to. And you can see our residual plot, again, with a really pronounced U shape there, indicating this probably hasn't been particularly successful in linearizing the data. Okay, so after performing those 3 transformations, it's pretty clear that the first one was the best. So we're going to push on with the rest of the question. Question 5 says, which transformation gives the best result? And it was definitely log number of seeds, the first one that we did. Okay, and explain our answer. Well, it has the highest R² value. Scatter plot appears linear just to look at it, and most importantly, it produces the most randomly scattered residual plot of the 3 of them. As we said, there was maybe a little bit of a curve at the start, but pretty random scattering, and definitely much more randomly spread out than the second 2, where there was a really pronounced sort of U-shaped curve. Okay, question 6, calculate the least squares regression equation for the best transformation. Express your answer in terms of the variables. This one's a little bit annoying because we actually have to go back and redo the first transformation. So back in our calculator into list 3, we're going to hit, we don't want list 1 squared anymore. We want to go back to log 10 of list 2 because it was the log y transformation. Get those values back there, calc regression, linear reg. It's the log y transformation, so the y values are the ones that changed. Hit OK, and there's our equation. Okay, so, and notice we had the R² of 0.9998, which rounded to 100%. But this time we're interested in the equation. Now the calculator writes it as y equals 0.28965. That's the value of A. Excuse the bell there. So y equals 0.28965 plus the B number 0.2012 times x. Okay, that's the equation if we were to just copy it straight from our calculator. But in terms of the variables, we know that the y variable is number of seeds and the x variable is row number. But we also know that we took the log of y. So our equation written properly is log number of seeds equals 0.29, if we go to 2 decimal places, plus 0.20 times row number. Okay, so that's how we get our answer for question 6. Questions 7 and 8 are both prediction questions. So we're going to take our equation and make some calculations with it. So I'm going to just pop back to the main screen here. Question 7 says, use the equation to predict the number of seeds to be planted in the 9th row. So we're letting the row number equal 9 and then trying to figure out the number of seeds. Because we have log number of seeds, I'm going to set this up as a solve and go action advanced solve. It's log 10 of, well, number of seeds is our y value, so we can use y equals 0.29 plus 0.20 times 9, and I need to tell my calculator to solve that equation for y. And we get y equals 123.026, which actually rounds to the nearest whole number, to 123 seeds. Question 8, predict the row number in which we would expect 350 seeds to be planted. This time we're letting the number of seeds equal 350 and trying to solve for the row number. Again, we can do this as a solve. It's log 10 of 350 equals 0.29 plus 0.20 times x. And when you're using x, you don't have to tell the calculator what to solve for because it will automatically try to solve for x. And we get 11.27, which to the nearest whole number would be row number 11. Whew, bit of a long one. Went through things pretty quick there, so if you do need to go back to anything, make sure you rewind it and have another look, and make sure as well that you can do this process on your own calculator, as well as just watching somebody else do it. Have fun with your transformation questions.